session is a 50-minute talk, or 40-ish minute probably, talk about the introduction to Yubikeys, what they are, how you can use them, and all the rest of it. So you probably by now know who I am. I am a DevOps freelancer. I'm currently working in Berlin for a company called Qubits. There's email, there's Twitter, there's GitHub. The GitHub stuff is relevant because I'll be writing some documentation and help for Yubikeys in the next few weeks so that people can actually get them started. Because the last 3 companies I've worked for, I've been doing Yubikey rollouts in various forms. And while I understand this stuff, it becomes clear that a lot of people find it quite difficult to understand what a Yubikey is. I've used them for years, so I have a sort of fairly deep knowledge of what you can do with them. Come on, there we go. But first of all, just sort of a little background on what we're actually trying to solve. Do you want me or the slides? So the question of what we're trying to solve is, so there's 2 bits to it. The 2-factor authentication. Us humans are, we don't play well with security. Usernames and passwords are hard to remember. People recycle their passwords. People use password 1 with a capital P and the number 1 at the end because it fits all your password complexity rules, but it's dead easy to remember. It's also in everybody's password list, please don't use it. We also don't remember passwords very well. We forget them, we write them down, we stick them on post-it notes. Every few weeks there's a data breach because somebody's left their password structure monitor and a TV camera's gone past it, or a high-resolution camera or just a normal SLR camera has caught a picture of their password. Passwords are really easy for attackers to reuse. If you've got somebody's username and password, you are that person. The computer doesn't do any further checking for a username and password if you actually are that person. There's so stuff without 2-factor authentication, they don't make sure you are who you say you are. The second thing which we solve with Yubikeys is cryptographic key storage. Cryptographic key storage is difficult. Generating key materials safely is hard. You generated it on your laptop. Do you know what software is running on your laptop? Are you aware of every piece of software on your laptop? Is the software sending your keys to somebody else in, for example, China or Russia or the US government, depending on pick your enemy? Generating good random key material is also technically hard. Computers are deterministic machines. Generating a random piece of information is actually very technically challenging. And even Yubikey have got it wrong, which we will you'll see towards the end. And the second part of storing key materials is you actually have to store it safely. How many people use SSH keys here? How many people have got a long, complex password on them? Oh, so that's looking up. That's better than my usual talks. But knowing where your keys are, knowing where your key material's been left, where it is in memory even, because when your SSH agent has your key loaded, if somebody controls the server you're logged into, they can extract all your keys. They can say to the agent, give me all those keys. And the private key material will go over the wire, the SSH agent will deliver it to the attacker on the remote server, which is very useful. Managing key materials is difficult. We forget where we've left files. We forget, oh, we used our key on this laptop, or we had to put our key in this Docker container because, well, we had to pull a Ruby gem from some internal Ruby repository. I know that when I take these out, these are the only copies of my keys. They were generated offline. They've never left these keys. I take this out of the laptop, and my laptop no longer has my keys. I'm certain about that. Humans are good at managing physical tokens. We've got lots of practice at keeping track of the house keys. We've got lots of practice of, oh, we'll have a backup key in the office safe. It's dead easy to explain to people, you've got a key, don't lose it. Rather than, you've got a password which is this long, please memorize it, then eat the piece of paper. Oh.
I didn't do it. There we go.
Right. So, this is a Yubikey, this is a USB-C Yubikey, this is a Yubikey 4, there's a Yubikey Neo somewhere in my bag I can't find at the moment. Excellent, thank you. So Yubikey is a small USB device. They're very robust. There's no moving parts. They are so they are tough. You can lose them. I've lost them. I've left one on a Reaver Trains Wales train somewhere in Chester. I've never saw that one again. They have they just plug into a USB port. They've got the contacts, and the sort of makeup of it is just one single solid piece of molded plastic. The button on top of them is capacitive. It's not a mechanical button, it's a capacitive button, so you can't wear that out. And you have to be a human being to press it. You can't press it with a machine, unless you've got a machine with a sausage finger. They come with multiple secure applets. You can think of this as a computer. It actually uses something called a Java card inside. So inside here, this thing runs Java. Don't all sigh at once. They are, so there's USB-A one here, there's USB-C one here, the Neo key supports NFC. It only really works with Android apps. The iPhone's NFC implementation is indifferent at best. But we also, so these are the various things. So this is a key which just does U2F, which we'll cover later. That's a Yubikey 4, that's a Neo, that's USB-C. So same as this, but smaller. These are again smaller devices. If you know anybody who works with the big web scale people, I know there's an ex-Googler in the audience. All of your laptops will have had one of these. All the web scale people's laptops have one of these in. My brother works for Facebook. His laptop has one of these in its USB ports. This I found. This is an X-ray of the insides of a Yubikey Neo. You can tell that by the wireless thing there. So you've got your USB ports, USB port here. You've got a secure a USB interface chip here, which is not in the secure zone. This is a secure zone chip. So it's designed to be secure. It's designed to be tamper evident. It's designed to destroy its keys if you try to break into it. Strip the top off it. If you try to fiddle with its power or its temperature, it will destroy the key material. People have spent decades perfecting these. They're very low power, they're not very clever, but they are pretty secure. And they're certainly much more secure than your computer. Because your key material is generated here, your keys are stored here, and the Yubikey software is written in such a way that you can never take your keys out of it. Yes, it's written in software, so you are still looking at software guarantees rather than hardware guarantees, but the software guarantees are pretty good. Up until the Neo, these were open source devices. Unfortunately, Yubico made the choice to move these towards being a closed source standard. They've had some pushback from that. Their answer is basically doing open source development for these and for these was impractical. There was so little expertise in the community. It was so hard to get hold of the hardware. That it just wasn't happening for actually doing real open source development. You can still get these, and you can still put your own applets on them. And I shall press the mouse pointer. Come on. Excellent. So you can still get the applets of these. They are still available on Yubico's GitHub site. But that's the hardware. This is what's inside Yubikey from a software point of view. So this is my Yubikey 4. This is a management application, Yubikey Neo Manager. Yubico's software naming and general documentation is indifferent again. So this is it's described as a Neo Manager, but it talks to Yubikey 4s as well. So we've got 1, 2, 3, 4, 5 applications which we'll go through. And we can also turn off different parts of the application. So that's one-time password is the sort of the original Yubikey. Originally, they've been around for a long time. The original generation of them, you just had 2 slots, and you could store passwords or little bits of information which you got back with. You could provide a challenge, and you got a HMAC back, a HMAC hashed, answer back with your challenge hashed with a secret in the key, burnt into the key. U2F is a much newer standard we'll talk about, and CCID is these smart card things here. So the first thing we've got is a one-time password, which is sort of the original Yubikey re-implemented. It has 2 slots, which you use to store long static passwords. A former colleague used to store all his passwords on Yubikeys and had to collect them around his neck. I disagreed with his choices because it meant you could get his password by stealing his collection of Yubikeys. Ta-da! He insisted it was better. I got bored of arguing. One-time password, it's when you have a Yubikey, you press the button and you get an identifier for the Yubikey and a long string of random passwords. That is combination of time, counter, and a tangling with the secret inside the Yubikey, which is then verified by Yubikeys servers. So you can also run your own servers, but by default the keys come preceded with a secret which Yubikeys has a copy of, and they act as an authentication source for that. They act as an authentication that yes, this is the Yubikey which we said it was, and here's the proof. You can also do a HMAC-based challenge response. If you plug these things in and use the right tool, you can submit a string of characters. You get a different string of characters back, which is a HMAC answer. You can use that for things like unlocking your encrypted drives. So I have a shell script which unlocks Lux drives with it. It's not very pretty, but it does work. This is not coming out very well on the screen. It worked much better on the big screen in the other room. I did check. It's the authentication flow for the one-time password stuff. I won't bother going through it unless anybody's particularly interested in it. Good. You've all met so this is the next applet, this one. You all know about Google Authenticator, the rolling six number passwords. The way they work is you have a secret, and that secret is stored somewhere on your phone or on your computer or in whichever authentication device you use. It's also the same secret, the same piece of secret of cryptographic material is stored on the server at the remote end. This is not bad as a two-factor authentication. If it's the only option you have, use it. But bear in mind that the secret is shared. If somebody has access to your phone, if somebody has access to the servers, they can impersonate you even with two-factor authentication. This, which I think, in fact, this is the other part of it. So this is the familiar rolling numbers. They are very easy to phish. Well, easy-ish to phish. So you prompt for the username and password, you prompt for the code, they've got 30 seconds to use that code. That's plenty of time to break into an account if you automate these sort of tools. They can ring you up, they can do the usual attack of, hello, we're your bank, can you log into this website? Oh, you need to give us your code as well, or you need to give us the code over the phone, log into the website, and they've got enough piece of information to go and impersonate you. Some people I know store the shared secrets on a laptop because it's convenient that way. They can copy it from one home directory to another. It is convenient. It's not how I do it. Also, when you, how many people have wiped their Google Authenticator by upgrading their phone? It's quite easy to do. It's very inconvenient to recover from. Yes, you can lose your YubiKey. Yes, you can break your YubiKey. You don't upgrade your YubiKey every time Apple or Google push a new firmware out. So this is the thing we're talking about. This is the one-time password app. The key material is, on your side, is stored securely. You don't have the same software upgrade risks, the same hardware upgrade risks. You can also enforce having to touch the button on the YubiKey and also optionally provide a PIN. So your key material that you're managing is protected by YubiKey's hardware and by enforcement of a PIN, and you only get a code when you actually touch the key. So again, it's all proving that a human being is present. It doesn't prove it's your human being, but it's a human being at least. So these are the more complicated things of the Yubikey. So we're now on to OpenPGP and Yubico PIV. So a smart card is a standard that's been around for a long time. There's various implementations of it. PIV stands for Personal Identity Verification, and it uses the PKCS11 standard. There are various open implementations of this standard, and it's widely used, particularly in continental Europe, for identity tokens. Estonia issues a PKCS11 token to every single one of its citizens as proof of digital identity. It's been around for a very long time. The PIV application is basically a Java applet which runs inside your Yubikey and can store on the new Yubikeys up to 25 certificates. On the older ones, I think it's 6. And they are X5 and 9 certificates. You can generate them on the key, or you can generate them off key and push them onto the key. They're basically TLS or SSL certificates. You can pull in, as I say, pull in existing keys. So this is my work Yubikey and also my work door key. And that has my VPN credentials for my Office VPN. Still requires a PIN to actually be able to log in. You also require this plugged in to get into my Office VPN. This is proof of concept rather than anything more than that. But the thing you can use these for is code signing. So Google, Microsoft, Docker allow you to sign the code that you produced and say, I wrote this code, I have compiled this code, I certify this code is what I say it is. They can also be used for system login. So Windows supports PKCS11 login. Essentially, you generate the certificate on the key, and you get a certificate signing request. You submit that to your domain controller. Your domain controller signs that certificate and sends it back to you. You load it onto your key. You can log in with that key to a Windows domain. There's also similar support from macOS, and I'm assuming there's Linux support because there'll be a PAM module for it. There's a PAM module for everything. I haven't bothered with it on my Mac because when you use it on your Mac, it changes your keychain password to be your Yubikeys PIN, which is unideal, rather than the proper password I use. You can also use it as part of a certificate authority. So you can use this as a root of your certificate authority. You could use it as a sub-certificate authority. So the way I use this is I have a master certificate authority offline, and I generate sub-certificate authorities on here. And I use that to sign things like VPN keys for all my various devices scattered around the world. It means that I can sign keys relatively easily, but I can also revoke a certificate, and it's all handled in hardware.
How many keys will it hold?
It will hold 25. The new ones will. The old ones are 6. The support is really there for about. There's good support for 4 of them in various different forms. You can also have lots of other old ones for historic reasons. You can also generate this. So as I explained with the Windows stuff, you can generate the certificate on the key, and you can send a CSR out automatically, so the key never leaves that. And a design implementation I did for a customer down in London is they issued the devices to their staff. The staff ran a shell script which generated the keys, prompted them for a PIN, issued a CSR through Slack. Their security officer signed the CSR and sent it back to them through Slack, and they loaded it into the Yubikey again with a shell wrapper. Thank you. You can use to store your SSH keys, or rather, you can generate an SSH public key from this. So with certificate authority, PKCS11 certificate, the RSA key behind the scenes can be spat out in SSH format by using PKCS11 libraries and SSH agent. So you're now getting, I need this plugged in to get my SSH key, which is what I do. It is finicky. Because PKCS11 libraries are finicky, because it's low-level implementations of talking to USB devices. If it's all you're doing with the keys for SSH, I would use a different smart card standard, which we'll get to next. If you want to do things as well as VPN credentials and SSH key storage through the same key material, it's not a bad implementation. If you came to my talk last year about certificate authorities, you can also have your SSH key published from PKCS 11 as a signed key, so you can actually do the whole certificate authority piece. I've got hardware key and I've got a signed certificate authority, so I can log into things. The other smart card standard, again, it's all applications, so we're now talking about OpenPGP. It's again a very old standard. OpenPGP cards have been on the market for a long time. The thing that Yubico have done is they produce a good form factor, and they've produced a card which can do lots of things at once. So for GPG, it's hardware key storage for GPG again. You can import your existing keys. It provides 3 key slots. If you know GPG, you'll understand the difference between these. But essentially, the signature key is the key which is your primary key. It's the one which you sign things to say, I am who I say I am the owner of this key. It generates an authentication key, which is what you use to log into systems. And it generates an encryption key, which is what you use to encrypt your file, encrypt content. Your signature key signs all of these, so to say, I'm this person, this is my key for encryption, this is my key for authentication. I use this for my SSH key storage, so I use the GPG agent to provide my SSH keys. It works really well. I pull my key out, my keys are no longer present on my laptop. I plug it back in, I type my PIN in, it's all done. I sign all my Git commits with this, so I can't commit code without actually having my YubiKey plugged in. It means that the code and GitHub has the public half of my key, so all my code it says I've committed this code, I've done this. Also use it for email signing and encryption. There's pretty good support now in most operating systems for signing email, encrypting email. Whether this is worthwhile is a whole different question. I'm not here to tell you it's worthwhile or not, I'm telling you how you could do it. The final piece, which is Yubikeys' sort of big thing now, which is Yubico U2F, and then recently announced FIDO2 stuff, which I haven't had time to do any reading on. U2F is designed to be a very strong second factor. It is very hard to phish because it requires this device to be plugged in. It's based on public key cryptography, so no longer with the TOTP, the rolling number codes, that's symmetric keys, same key material on both sides. This is now public key. So the private key material on here, we send a public key to the upstream provider, and they will authenticate that this key is bound to this account, and this is the public half of it. It's recommended by Google. Basically, Google's strong authentication standard is you have a YubiKey. That's their recommendation for all of their strong authentication, all of their high-risk customers. If you work for the US government, that sort of thing. Or if the Russian government wants to do your emails. Facebook, as I've said already, they use these for U2F. You can now sign up for 2FA with Facebook with U2F. I go through all my accounts that support it, turn U2F on, remove my phone number so they can't send me SMSs for password resets. I keep the TOTP stuff on because it's a good way to get back in when I lose my YubiKey. GitHub also support U2F. It's also really user-friendly. The login flow is log in, type your username, type your password off your post-it note, plug your YubiKey in, press the button. And that's done your strong two-factor authentication. That's it. No longer necessity to type in numbers, no longer need to find your phone to log in. Yes, you do have to plug your YubiKey in, but details. This isn't great on this rather smaller screen. The essential summary is you have a private key on your device, you generate some random noise, you mix it with an identifier for the web service, usually a URL. You send the public key out here, so when you've logged in, the public key gets sent to the web service. The web service remembers that. And when you want to log in again, you can prove you control the private key with the standard sort of challenge response stuff that's built into public key cryptography. There's a great deal more detail behind that. That's a high-level summary. I have a secret in my device. This is a URL which I have provided a public key to. I can now prove I control the private key to that URL. When you should use your YubiKey. I had a conversation on Twitter with somebody who was trying to understand how to load the GPG applet into the second slot of his card. He was a technically literate user. It's just really poorly documented. So if you're signing code, if you're signing Apple code, Android code, Linux code, Docker images, use smart cards, enforce the touch to sign on the YubiKey. You can enforce that, so you have to touch the button to sign the code. If you're using Google, GitHub, Facebook, GitLab, 2FA, use U2F. It's simple, it works, it's really strong. If you're a LastPass user and you want to use 2FA, they support Yubikeys one-time password, which is a very old standard that Yubikey have re-implemented in Java. They authenticate that off Yubikeys servers, but it is a strong second factor for LastPass. LastPass is one of the few big sites that support this. If you want to store your SSH keys securely off machine and easy to move around and unplug, use smart cards, either the OpenPGP or the PIV standard. I would use OpenPGP, but PIV works as well. PIV is just finicky. Email encryption and signing, smart cards, either OpenPGP or PIV. That's SMIME, that is GPG. If you want to log into a system, use smart cards with PIV. All the major operating systems and most of the minor operating systems support smart card login. So, summary. I really like the YubiKey hardware. It's well made, it's well thought out, it's badly documented. Yubikeys handles security issues well. There was a security issue with a whole generation of these keys. There was a firmware bug which was found by some developers who I can't remember, and it wasn't YubiKey's fault. It was the chip manufacturers had provided broken standard library code. They replaced hundreds of millions of these for free. I basically gave them the serial number of this and said, they validated it was a broken one, and they sent me a new one the next day. The organisation I was working for at the time, we had 150 of these cycled within 2 days. It was deeply inconvenient for our users and for me, but the hardware was handled and fixed. U2F works really well. You can buy a U2F only key. That's right at the start. That's this one. That just does U2F. It's the same hardware as all the rest of them, but it's only got one applet loaded. And it's a really good second factor to start with. It's dead simple to use. It gets you exploring the idea of what you can do with it. There's also U2F support for PAM. There's a PAM module for it if you want to go and experiment with using this on your servers. Hardware SSH keys, GPG is much easier. It's much less finicky. It just works. For most people, I've used these for years, and I've brought these into businesses with large numbers of technical users, and it is hard for them to understand the process that they're using. It's hard for them to follow. So if you are bringing it to your organisation, spend the time to write the documentation, or pay me to write it, or pay me to re-implement your documentation with your name at the top and the code the documentation I've already written. The tooling is the naming is inconsistent, the tools vary, you can't use PIV and GPG at the same time for reasons. The GPG people won't change a setting that they're using for alleged security reasons. There's arguments about it. Other than that, I've stolen some ideas from here. This is where you get all the developer tooling from Yubikeys. How am I doing for time? Excellent. That's just the answer I wanted. Questions?
Have you got one for a washing machine yet?
Yes.
Does it work still?
Absolutely perfect.
I wear it in the shower. 15 minutes. You've got 15 minutes.
That's about right then.
Just to confirm, you said that when a Neo is being used in top P oath mode over NFC,
yes,
you can enforce not only a PIN requirement but also a button press requirement.
Pass. I've never done it. I have an iPhone, so I've never really played with the NFC stuff. Yep.
If you are thinking phone use teenagers,
Yes.
which is it the UTF is probably the best thing?
It's a good starting point, yes. So you can enforce that on Facebook and on Google, which covers a big chunk of their digital lives.
Because they don't have to be passing in the line, they just have to be passing before the send.
Correct.
Do you know offhand if the Facebook login works on the phone? On a mobile?
That's why I have I've got the rolling password as well on there. Right. But the most of the login stuff now is done with there's a captive web window. Look, I know the iOS ecosystem better. There's a captive web window, which you can do the full sort of authentication stack.
Cool.
Excellent. Nice and simple.
Sorry, what's the cheapest one?
The cheapest one is the U2F one.
And how much are they?
I think the U2 18 quid.
Okay.
So that one's 18 quid. That one's 40. That one's 45 because don't make as many and it's got wireless stuff in it. Those are a little. I think those two are the same price. Those two are more because they're just smaller. And I assume the yield is lower because they're much tighter space-wise. So these things you can put if you've got if you still run your own actual real tin servers, you can put these inside, so you can actually have keying inside your servers. Yubikeys also produce a USB-based HSM hardware security module, which is £500 rather than £50, and there's quite a lot of good tooling around that for sort of HSM type functionality. It's a good step into the HSM world if you want to do things like signing keys for build servers. If you've got physical tin servers you build with, you can sign all the output from that server, and you know the keys are only in that server and only on that physical device.
All my YubiKey use, I've generated the keys off the key and then put them onto the key myself.
Yes.
Because I get a bit hinky about people's hardware implementations of RNGs.
Yep.
What do we know about the quality of Yubikeys RNG?
We know it's FIPS certified. We know it's FIPS 140 certified. We know that this is an Infineon chip inside it because that's where the bug came from. If you've generated off key and loaded up yourself, you've dodged one of the bugs. To be fair, that's what I do. I have an offline Raspberry Pi that I generate my keys on. You can argue that's a little bit obsessive. It has a serial port, and I plug in a Yubikey, I generate some keys, I populate my Yubikeys. I did it as an experiment to understand all the pieces, and the pieces are very complicated, particularly when you don't have internet access and you can't just install a package. But it did teach me a lot about how the innards of these works, how the edge cases and the tooling. And I now have a reasonably good way of managing my certificates and GPG keys. So when I leave one of these on a Riva Trains Wales's seat, I can rebuild them fairly quickly.
As an addendum to his Raspberry Pi bit, I use a Tails USB bootable, which comes with GPG and all the basic tools you need to do an offline one. And the nice thing about the Tails one is, even if you've not got it plugged in, you can also disable the network adapter before it even boots. So if you're interested, tails.boum.org is the OS, and it is designed as it wipes itself on shutdown.
Yeah, it's got some manual shutdown and such.
And also, actually, if you generate a GPG key and use it on there, or have a GPG on that separate thing, it also has GPG secured partition on the USB stick for secure storage, and it's used by reporters in places where they will probably get shot for what they're writing.
That's the man in Syria did get shot for.
Yes.
Excellent. Thank you for your attention.